Vanakkam. Welcome to this course on classics in neuroscience. In this series of videos, we are looking at the development of theoretical neuroscience and how we can consider the brain as a computer and the computer as a brain. In this video, we will look at the contributions, the phenomenal contributions of John von Neumann to this field of computing. John von Neumann was born in Budapest in Hungary in 1903. He graduated in mathematics in Budapest, and he also graduated from chemical engineering at ETH Zurich in 1925, and in World War II. So, he then emigrated to the United States, I think around 1930, and in World War II he became a member of the Manhattan Project to build the atomic bomb. And he had heard the work of Macaulay and Eckert, who built the next generation computer, the ENIAC, and he decided to develop his own variant, an improved version of the computer, which he called as EDVAC, the electronic discrete variable computer. This computer had improvements over ENIAC in terms of stored program to run computations through the central processing unit, and it had a memory for both data from computations and the programs that ran them. Of course, he was strongly criticized by some people such as Vannevar Bush, who had a key role as the science advisor to the president. But still, the fame and the big name of von Neumann held its ground, and von Neumann could proceed with the building of this EDVAC. This is the EDVAC computer. It is now seen. So, von Neumann, the picture of von Neumann is shown here. He recommended the following things while building a computer. He said there must be a central processing unit which does all the arithmetical and logical operations, and a random access read write memory that stores programs and data that can be accessed at any time rather than being accessed sequentially. What is the difference? The difference is, if you can randomly access them, you can access them fast. If you have to sequentially access them, you have to access all the data that are stored before a particular data of interest. So, the sequential data storage would be, or sequential data access would be very slow. And he suggested the use of binary words in series rather than in parallel, instead of operating on every bit. This is somewhat surprising because parallel computers are faster than series computers, but still he came up with this idea. A question is, what exactly was the source of von Neumann's ideas? It is believed that there were two primary sources. One was interactions with what was the source of von Neumann's ideas. We speculate that it could be from two primary sources. One is based on his interactions with Atanasov, who had built a computer based on binary logic, ABC computer, and von Neumann himself had an excellent understanding of the functions of biological systems, in particular the brain. So, he used his insights of brain functions to develop or to build a general theory of digital computation. So, he said that there are neurons in the human nervous system. Likewise, you have the central arithmetic, central control and memory, that is in sensory or afferent system. Likewise, you have the inputs, you have the motor or the efferent systems. Likewise, you have the outputs, and like you have the all or none characteristic of the action potential or of the neuron, that is either silent or that is excited. You have an excitatory synapse that causes an excitation and an inhibitory synapse that absolutely prevents inhibition. This can be imitated by relays, as was discussed and shown by Claude Shannon. or by vacuum tubes. So, we can also incorporate synaptic delays by using synchronous setups. So, but of course, more complicated things like thresholds, temporal summation, relative inhibition, synaptic delays were not completely described. So, these synaptic delays could include could be introduced through vacuum tubes and can be used to build counters and scalars and some reaction times that are in microseconds, whereas synaptic time of a human is of the order of milliseconds. So, these analogues of human neurons and the principles governing the arithmetical operation and the all or none characteristic of the action potential and the neurons align well with binary system. So, he suggested we can use vacuum tube systems similar to Atanesov's original machine. As of now, a lot of neuroscientists analyze the brain as a computer, and in the beginning the computer was built to resemble the brain. With this, we come to the end of this video. In this video, we looked at the computer and the brain and the phenomenal contributions of John von Neumann, in particular to build the computer EDVAC. Thank you for your attention.